we're going to have a look at the proof section now, and we have these 4 rather innocuous looking proof questions. But they're all contradiction, and until you've really got your head around contradiction, these can actually be really, really difficult. This one here, the root 3 is irrational, is just a complete replica of the root 2 is irrational that you need to know for the course. So this is just essentially changing 2's to 3's of a proof that you've got to know how to do. So we're going to have a look at this first one. So this is question 8, prove root 3 is irrational. So the first step for all proof by contradiction questions is to work out the mathematical opposite of this, which is going to be root 3 is rational. Now rational just means we can write it as a fraction. So I'm going to write that down. Assume negation, which is that root 3 is rational. Root 3 equals a over b as a fraction, where a and b are members of the integers, and a and b have no common factors. So if things have got common factors, they can cancel down. So what we want is root 3 to be written as a fraction in its lowest possible terms. This bit here is just extra mathematical rigour. You might look at this and think, how would I have thought to do that? There's one in the textbook for root 2, and you've got to know that proof off by heart. And you've got to be able to adapt it for 3's and 5's and that kind of thing. So we've got our a and b as a fraction where they have no common factors. So if root 3 equals a over b, then we can write it as 3 is a squared over b squared, which then means we can write it as, by multiplying up here, a squared is 3b squared. So all we've done here is done a little bit of rearranging. We've squared both sides, so we've multiplied up and we've changed it round to make it look like this. What we need to do now, as a squared is 3 lots of b squared, then a squared must be a multiple of 3. The way square numbers works, if a squared is a multiple of 3, then a has to be a multiple of 3. It's quite hard using a as an object and as a letter when you start writing sentences. What we're going to do now is we're going to make this a 3k for some k. So if a is a multiple of 3, we can write it as k, 3k. So if a is 6, k will be 2. If a is 18, k will be 6. If a is 17, well, it can't be 17 because it's not a multiple of 3. So for some k. What we can do now is we can go back to this bit, so we can write out 3k squared is 3b squared. Expand this, so we get 9k squared is 3b squared. Divide by that, giving us b squared is 3k squared. By the same logic we had up here, this implies that b is also a multiple of 3. This is now a contradiction, so you need to use the word contradiction in the exam, otherwise you won't get the marks for it. This contradicts a comma b have no common factors. So we now had a conclusion. So this proves root 3 is irrational. So we've got our contradiction here. It contradicts the fact that a and b have no common factors. So this negation that we assumed up here cannot be true. And because this was the mathematical opposite of root 3 is irrational, we get our root 3 must be irrational. All the other proofs are a copy of this, but some of the working in between is different. It's still got our same steps. Assume the negation. We're going to do some working out here and show that the negation has a bit of a problem. We're going to conclude that there's a contradiction and our negation is rubbish. And we get our conclusion at the end that says therefore the original statement is true. It's exactly the same layout for all the rest of the proofs.